how do you use the recovery machine, how do you use the vacuum pump to pull a vacuum, and how do you charge a mini split. We're going to be recovering the refrigerant on the mini split, we're going to be pulling a vacuum, and we're going to be charging this mini split. And I'm going to show you what the conditions are when a mini split doesn't have enough refrigerant. You're watching Taddy Digest. I'm Tad. Let's get started. The first step for recovering the refrigerant is you got to make sure that the mini split doesn't have any power. This is a solar powered mini split, so we got to cut the DC power, which we just cut the DC power by taking and turning off the PV isolator, isolating the solar from the mini split. And now we're going to take the AC disconnect and we're going to pull that disconnect, and that will completely shut off the unit. Now I'm going to show you the tools we're going to use to be able to recover the refrigerant. This is a recovery machine made by NAVAC, super light, portable, and it's compatible with A2L refrigerants. This right here is a NAVAC set of scales because I like to weigh out the refrigerant. Then we've got our gauges. We've got an extra quarter inch hose, and then we've got our 15-pound recovery cylinder. I've already prepared the cylinder. If you want to learn more about preparing a cylinder, I've got a video specifically on using a recovery machine and how to use it, and I'll put the link to that video here, also in the description. So first thing we're going to do to hook up the recovery machine is we're going to plug it in. So we got a plug, it's 110 volts, and I've got it plugged in to this 110 volt receptacle. Now we're going to take our gauges, and I'm going to be using my blue hose, and I'm going to hook it to my adapter. All right, here's my 1/4 inch to 5/16 adapter, and I've already got the cap off. This is my service access fitting connected to my suction line service valve. This is the larger valve on the mini split, and this is known as the suction line or the hot gas line during the heating mode. So we're going to take and we're going to hook up that fitting, and then we'll be able to read the standing pressure because the unit is no longer on. So we're reading the standing pressure. Once it's hooked up, it's going to go from reading 0 to whatever the pressure is. So it is 210, looks like. Now what we're going to do is we're going to take the yellow hose and we're going to take it off of the manifold, and then we're going to hook it to our recovery machine. And you'll notice on the recovery machine there's an in and there's an out. All right, we're going to go in. So we're going to take our cap off of the port that's labeled in, and we're going to connect our fitting, our yellow hose, straight to the end. All right, once that's connected, then we need one more hose, right? So we're going to take that other hose and we're going to hook it to our outlet port. See where it says out? Now we're going to connect this right here, and then we're going to connect the other side to our recovery tank. Now, what I like to do is I like to keep my recovery tank closed. Then, make sure I got power on my recovery machine. I've got power. And then what I'm going to do to start recovering that refrigerant is we're going to take and open our yellow valve on our manifold gauge, and then our blue. This is going to allow the refrigerant to exit the mini split, run through the blue side of the gauge, exit through the yellow, and into our recovery tank. Now we can take and turn this knob. Come over here. See this knob? This dial handles the purging and the recovering. And you're going to take and you're going to turn this dial to where it says recover. They've got slow and fast because you can actually adjust the speed that this recovery machine recovers that refrigerant. So you can see our hoses are now filled with refrigerant, and what I like to do is I like to bleed the hose at the tank, and I just want to bleed that air out of the line because we're not wanting to recover air, we're wanting to cover refrigerant, right? Now we're going to set up the scales. I'd like to know how much refrigerant we actually get out of the system and we're able to get inside the tank. So this is a set of scales made by NAVAC. You take your finger, you push right here, the remote pops out. I love this set of scales because it's super lightweight. We're going to take our refrigerant cylinder, recovery cylinder, and put it on the scales. And then we're going to take and push the power button. And then we're going to push the power button on the remote. What's nice about the remote is there's a little stand right here. So we take the stand, set it here, and it says what? Our cylinder weighs 8 pounds. So we're going to take and push the clear button. That's zeroing it out. And now we're going to take and we're going to recover, but we're not going to use the machine first. We just got to make sure this is open. If you want to adjust the unit from grams to pounds, push the unit button. There's ounces and pounds. I like that. Now we're going to take and open the tank. And since the pressure's higher in the system than it is the tank, it's going to equalize. So we're going to be able to pull out some of that refrigerant without actually turning on the recovery machine. So that's nice. So you can see what's happening. See? Pressure is going down. We're going to do this until it stops, and then we're going to turn on our recovery machine. We're going to bring this back to where it says slow, and then we're going to turn on the switch. Pa-ching. Push this button. And there it goes. And you can adjust the speed up and down. Whoa, look at that. It's pulling that refrigerant out. Let's let this run for a minute. Now if you look at the remote for the scales, you can see how the pounds are increasing, the ounces are increasing, and we're actively recovering the refrigerant from the system into the tank. And I'm timing this to see how long it takes to recover the refrigerant out of a mini split. Now let's look at how many pounds this holds. Looks like it holds 410A, 56.4 ounces, or 1.6 kilograms. So this system, if you take and divide 56 into 16, you'll see it holds 3.5. So about 3.5 pounds. Now if you look, it's almost down to 25 PSI. Looks like it's at 30. And our scales say 1 pound, about 10 ounces. So we're almost there. All right, we're here, we're at 0. So that means what we're gonna do is take and close our gauges. And then we're gonna take and we're gonna close our line going into the tank or the recovery machine. And then we're gonna turn the recovery machine dial to where it says purge. And it's gonna purge what's in the machine into our recovery cylinder. And when it hits 0, you're going to close this, turn it off, and then we're going to close our tank like this. And you can close the tank first and then cut the machine off. Now we're going to weigh, well, we've got weighed what we pulled out. So we'll check out the remote here in a minute after that tank stops shaking. So let's look at the scales. 2.48. This unit holds 56 ounces. That's not quite 56 ounces. So this could cause my mini split not to cool correctly. Let's look at the gauge. Looks like it's 0 still. Let's open it up. And let's take it off. So, yeah, there's nothing in there. If you want to recover the refrigerant from just the line sets and the indoor unit, you can close both of these valves with an Allen tool before you start the recovery process. If you close both of these valves, then you will isolate the outdoor unit from the line sets and the indoor unit. And then you can just recover what's in the line sets and the evaporator. That way you can take and you can remove the outdoor unit if you want to, or maybe you're replacing the outdoor unit. Now, for us to be able to pull a good vacuum, we got to use some nitrogen before we vacuum. You don't have to use nitrogen, but it's a good thing to do, especially if you want a really good vacuum pull. So you can also use this for pressure tests. Say you have flare fittings on your outdoor unit, you want to do a soak test, you can actually use your nitrogen. If you have quick connectors, you do a leak test with using a combustible gas leak detector or a refrigerant leak detector. So to use a nitrogen tank, we have to have a regulator, right? So we take and connect our regulator like so, and once we get our nitrogen regulator on our tank, then we're going to take and use our adjustable crescent wrench, and we're going to tighten it up like this. Then we're going to connect our yellow hose. And if you don't know anything about brazing, I've got a video on that. I'll put a link. And this is the adjustment screw. So you can run this screw out to decrease the pressure. You can run this screw in to increase the pressure. You can see right now we've got 0 on our gauge, right? We're going to open it up. Open up the yellow. And then we're going to open up our nitrogen tank. So watch this. Now watch as the pressure increases. See that? So we're just putting some pressure in there. Okay. Now I'm not going to put a bunch of pressure in here because I'm not doing a pressure test. I'm just doing this for learning purposes for you to teach you. If you're doing a nitrogen to pressure test and you've got flare fittings and you're doing a soak test where you spray those fittings, then you may need to pressure test with upwards of 500 psig. I'm not doing a pressure test. I'm just using the nitrogen so that I get a good vacuum. And the nitrogen is going to help me to remove the moisture and non-condensables. So I got the nitrogen inside the system. Usually I'll let it set a minute, and then I'll take and I'll remove the nitrogen by opening up the hose and the gauge. Now I'm setting up my vacuum pump. I want to pull a vacuum, right? I got my NAVAC vacuum pump, and it's cordless. I love it. It's battery powered. You want to be able to monitor your vacuum. You can look at your gauges, and you can actually get a micron gauge. A micron gauge, you can attach it to the pump, or you can attach it to a port on the unit from the furthest point from where you're pulling, and that will help you to monitor your vacuum level. Now that our nitrogen is almost out, we're going to take and connect it to the pump. Be careful when you're connecting your gauges and your hoses to your pump. If there's a lot of pressure, then it's going to blow the oil out of the pump, and you don't need that. Plus, it'll make a mess. This is NAVAC's DC vacuum pump, so it is compatible with A2L refrigerants. And what we're going to do to pull a good vacuum is we're going to open the ballast right here, and then we're going to make sure our pump is screwed on, our hose is screwed on, and then we're going to take and open up our valve. Open up the valve, and then push the button to turn on the pump. Now you'll notice on the gauge, take a look. See how it says 0? But look what's happening. It's pulling down, right? It's pulling down. It's going to pull down to 30. All the way down where the 30 is. And when it pulls down to 30, and then you turn off, which we got to close our ballast. When it pulls down to 30, and you take and turn off you shut your gauges, and you don't hear a sound of change in the vacuum pump, then that means you've got a good vacuum. Or you look at a micron gauge. So watch this. When I open this up, and then I close it, there's a change of sound, right? Listen. When we get a good vacuum, I'm going to show you that when you turn it off, there's going to be no sound as far as the valve going to the gauge. Now let's let this pull down for 15-20 minutes, and then we'll see what happens with our sound. Now, take a look at the gauges. It says exactly 30. We're going to take and close off our gauges and see if you hear a sound change. Listen. No sound change. Now the next step is once you shut off the pump, you take and monitor your gauge for at least 10 minutes. Sometimes you want to wait 30 minutes. And if this dial here goes up and it goes to 0, or it goes up above 30, that's an indication that we've got air entering the system, and that's making the pressure rise. And that's an indication we have a leak. You can also use a micron gauge. I've got a micron gauge. Today I'm not choosing to show you the micron gauge or show you how to use it, but if you want to check out a more thorough video and to learn how to use a micron gauge to pull a vacuum, I've got a video on how to pull a vacuum and use a vacuum pump. I'll put the link right here and put the link in the description. Now that we have pulled a good vacuum, we've used our nitrogen, we're going to take and charge up the system. And I'm going to show you how to charge this mini split. Now we're going to charge up the mini split, so we're going to take and connect our yellow hose to our tank. And then we are going to leave this valve closed, leave our gauges closed, and we're going to take and open up the valve on top of the cylinder. We're going to charge as not a vapor, not this way. We're going to charge as a liquid this way. We're going to turn our scales on. And once we turn our scales on, we'll hit the clear. Then we'll come over here to where our yellow hose is, and we will turn this on and bleed out the air. Bled the air out. And now we're going to clear it out one more time. Clear. And then we're going to charge in ounces and pounds. All right. So take a look. Let's open up our blue and our yellow. Yellow first and then blue. See how we're adding. And you can see that we've got 9 ounces, 10 ounces, 11, 12. So I'm going to show you what the conditions are, the temperatures, the pressure with a mini split being low of charge. We're only going to add a pound for now. I'm going to go ahead and turn my PV power on, my AC power, plug the disconnect in. Let's go turn the unit on. Turn the unit on cooling, temperature down all the way 61. I'm placing my dual induct psychrometer inside the up and down vane area. That way I can measure the temperature. And I'm going to leave this right here. I've got my temperature clamp connected to my gas pipe, suction pipe. I've got that clamp connected to my meter, and I'm going to turn the dial to Fahrenheit. And we're going to measure the temperature of this line right here. And we're going to measure the pressure and the supply air temperature. So it's been running a few minutes. Low side pressure is like 40. It's going down more. The liquid line is freezing. You can see it freezing up. The suction line temperature is 86. And when you look at the temperature of this line, it's an indication of the temperature of the indoor heat exchanger. So if we see 86 here, that means it's probably not blowing out cold air like we want in cooling. But you can see, look at this line, it's freezing up. So that's what happens when you have a low charge on a mini split. Pressure again is 35, right? And it should be on a 95-degree day, indoor dry bulb of around a 70, 75. It should be upwards of 110, at least 125. Let's go look at the supply air temperature. Supply air temperature is 66 degrees. That's not very cold. I mean, that's good if it's 86 degrees in here, but it's not 86 degrees in here. So that is not good. That's not a good supply air temperature. You want to measure the temperature above where the unit sucks in the air. That's the return. And then you want to measure the temperature here, and you want to get at least a 20-degree difference between the two. 66 is not going to work for me. Let's go add some refrigerant. All right, we still got about a pound of refrigerant, right? 15.6 ounces. It's still pretty low. Let's go ahead and add some more. Look at that frozen line. Oh, look what happened to that line after I started charging. Looks like it's not frozen anymore. And we've got what? 2 pounds now? All right, let's shut it off at 2 pounds. Now we're going to use something called Superheat to make sure that we have a good charge for this mini split. And Superheat is the heat added to a vapor after its boiling point. And I refer to Superheat as, is my indoor heat exchanger flooded or dry? And what we want is, we want a lower number, closer to 10 degrees of Superheat for a mini split to be charged correctly. Anything 30, 40, 50, 60, that means the indoor heat exchanger is dry or empty of refrigerant. Anything 20, 15, 10, 10 means it's got a good amount of refrigerant. It's a flooded evaporator. So how do we figure out the Superheat? Let me show you. So let's see here. We got 2 pounds, 1 ounce of refrigerant. Our low side pressure is no it's not, it's 75, it's 85. All right, our saturation is that pink line that lines up with R410A, right? Saturation is 23. So yeah, I'd say 23. So 23 is our saturation. Remember that. You get your saturation by looking at the dial that lines up with the pressure, and then where the pink line is, that number is your saturation. Then you take that number and you subtract it from the number for your suction line temperature. So this is our gas line temperature or suction line temperature. It went from 86 to 72. That means our temperature inside is going to be lower on that supply air. And if you take 72 and you subtract it from 23, then you've got about 50 degrees of superheat. And we want to make that temperature 10 degrees of superheat. So what do? We add more refrigerant. Before we do that, let's check out the supply air temperature again. Measuring the supply air temperature once again, it's 59. Before it was in the 60 range, right? So we lowered that temperature by adding refrigerant. It actually feels better. So 59, but we're not there. We're not there yet. Let's get there. Time to add some more refrigerant. This time, let's add the factory charge, or what the data plate says. Now we've got the exact factory charge in the equipment, 3 pounds, 8 ounces, which equals 56 ounces. Our low side pressure is 125. Our saturation is 42. We take 42 and then we measure our suction line temperature, and it's 54. Or 53. That's 11 degrees of superheat, so we're right there. Now our suction line is nice and cold. Before it wasn't this cold, it was warmer. Our liquid line it's warmer. It's not ice cold like it was. This should never be iced over. This right here should be nice and chilly. So now let's check our supply air temperature. Supply air temperature is 54 degrees now. That is much better. That is nice. So let's check out the exact return air temperature, and then we'll know what our split is. Measuring our return air temperature, 74. Nice. So we got exactly a 20-degree split. That's perfect. Factory charging a mini split is the best way to charge a mini split. You weigh out what you recover, and then you actually factory charge the equipment with what it's rated to hold. That's the best way to charge it. Using superheat will give you an accurate charge. So use your temperature clamp, use your induct psychrometer, and make sure you use your gauges and your adapter. If you don't have any of those tools, I'll put those in the link in the description for you. I hope you guys enjoyed the video. Now you should know how to recover the refrigerant out of the mini split. You should know how to use the vacuum pump to pull a vacuum, and you should know how to charge the mini split. And know that factory charging is the best way to charge that mini split. This is a HVAC Tips for Technicians video. I hope you liked it. If you liked the video, hit the like button, subscribe, and smash that bell. Ding! So you know what I'm doing. If you want more videos like this, go check out my playlist, HVAC Tips for Technicians. I've got hundreds of videos of live, real experience in the field as a technician to help you be a better technician. You've been watching Taddy Digest. I'm Tad, and I'll keep you cool if you let me.